Okay. Hi everybody, thank you all for joining. We are recording, yes. So it's my pleasure to introduce Dr. Oscar Kjell. Oscar completed his PhD in psychology at Lund University in Sweden, and he currently holds postdoctoral positions at Lund University, Stony Brook University, and the University of Copenhagen. Is that right?
Yeah, that's right.
Where he studies measuring psychological constructs with words and text responses analyzed with artificial intelligence. That means that Oscar develops innovative ways to study well-being and psychopathologies through natural language processing. In addition to his academic appointments, he is also a co-founder in a startup company, I believe, that applies AI methods in decision support system for diagnosing and assessing psychiatric disorders. Oscar, thank you so much for joining us today.
Yeah, thanks a lot for inviting me. I'm very excited and happy to be able to talk to you all. And thanks for the introduction of me. So please feel free to stop me at any time if you have any questions or you think I'm going too fast or too slow. Maybe one question is, how familiar are you with like text analysis and word embeddings?
Some of us more than others. So it's a heterogeneous crowd here.
Okay, but if you feel like, I think I'm going to skip a few slides, but let me know if you want me to go into more detail in any one of them. All right. Okay, so my aim of this talk today is to provide an overview of how to quantitatively assess psychological constructs based on natural language using what we called computational language assessments. And then in the end, I'm also going to provide some information about an R package that we've done where we provide these methods to social scientists and R users. Yeah, so here to start with, we have the traditional rating scales that you can find everywhere, almost everywhere in psychology, and it comprises a predefined item or questions aimed at reflecting the psychological construct that you want to measure. One such example is I am satisfied with my life, which is from the satisfaction with life scale. And this item is then coupled with a rating scale that the respondent is required to answer. So here it ranges from strongly disagree to strongly agree. And we argue that this approach comes with certain limitations, such as you have these predefined items where you, as a researcher, imposing your view of it, and this forced choice limit the respondent to really express themselves. And as a researcher, you miss out on information where they describe their unique experiences or symptoms. So therefore, we see some advantages of open-ended questions. First of all, language is a natural way of understanding other people's subjective experiences, and it's also the natural way often to communicate these experiences. And then you're not forced to answer on rather arbitrary rating scales, but instead provide reflective, open answers. So they allow respondents to answer freely what they perceive as important and relevant aspects of a psychological constructs. But these have historically been quite difficult to quantify. So that's why we started to use natural language processing and this method that we refer to as computational language assessments, or in the beginning we also call them semantic measures. But basically, we develop and validate an open-ended question such as, overall, are you satisfied with your life? And we couple this with instructions to let the respondent know that, for example, they can answer with a descriptive text. We've tried, We've also tried it with descriptive single words. So often we gave them like 5 to 10 boxes, and then in each box they could write one single word. So for satisfaction, someone very satisfied could answer with descriptive words such as family, achievement, money, fulfilled. And we've also tried response formats is a bit in between. So we've asked for phrases, descriptive phrases, or even select from predefined item lists. So that's an ongoing study that we have. And what's in common then is that we take these responses and we quantify them using natural language processing and machine learning. So the first step here is really to quantify the meaning of words with numeric representations. So we call them semantic representations or word embeddings. So an underlying assumption when creating this is that you shall know a word by the company that it keeps. So how you use the word and in which context you use the word sort of provides meaning to it. And this we can take advantage of by to create these word embeddings. And a simple way of doing this is that we can take a really large sample of language corpus. And then we usually, when we use this in the beginning, we usually use the 120,000 most common words. And then in the columns, we took the 10,000 most common words, and we made a co-occurrence frequency table. So what you can see, if you can see my mouse here, we already have a vector here sort of starting to describe apple. But then we can, on 10,000 dimensions, but then what we do is we take a factor analysis, and we usually got it down to approximately 500 dimensions, where then each dimension describes some aspect of this word. So these numeric values can be seen as coordinates in high dimensional space, and the closer two words are in this high dimensional space, the more similar they tend to be in meaning. And then we can start to use these. So here, for example, if we just think of 2 dimensions, we can actually plot out the words such as happy, and then we can take a word such as harmony, and we can see how similar they are positioned within this 2-dimensional space. And this type of method that I just described now for semantic representations or word embeddings are often called latent semantic analysis, which has been used in psychology since sort of the 90s, a bit earlier even. It's also called a bag of words approach, because here apple always get the same semantic representation no matter which context it is in. And for many words, this is a problem. So we can take this sentence, for example, yesterday I felt like a great failure. Today I feel great. Here, great has 2 very different meanings, but in a bag of words approach, great always get the same semantic representation. But then quite recently, around 2017 and 2018, in computer science, they developed a new type of language model that they refer to as transformers, which take the context a word was into account. So on the left side here, you have a bag of word model, and you feed the word I into the model, and you get a semantic representation or word embedding. But when it comes to transformers, this is very simplified. But here we let the surrounding words influence the word embeddings using deep learning, and like that we get the context. So in the beginning, we found when we use descriptive words versus descriptive text, responses, we found that descriptive words were much better. We didn't want people responding to say not at all happy. We forced them to say unhappy, which gave us sort of a better semantic representation. Whereas now, when we can use the transformers, we can also use the text responses to get really good results. So there you got a little bit of a background, sort of a very quick background of what a word embedding is. So if you have any questions about that, please let me know. Otherwise, I'm going to talk a little bit about how we use them in our research. Okay. So the history here is that I defended my PhD thesis, and the opponent was Andrew Swatch, which is now my advisor for my postdoc, and he's a computer scientist, and he came to us to visit us for a few weeks in 2018, and then BERT and the transformers, those kind of language models were brand new, and so he helped us sort of start using them. So the first thing we did was we took some old data, pulled together 3 data sets where respondent had both described their harmony in life and satisfaction in life with both text and word responses. And in all 3 studies, they started doing this in a randomized order. And then after, we had a block of traditional rating scales, the harmony in life scale and the satisfaction in life scale, which were randomized as well. And we tend to put the rating scales last because we don't want the items in there to influence participants' text or word responses. So we have a little bit more than 600 participants, all coming from the US. And then we take these into this analysis pipeline. We take each response. We use this language model, a pre-trained word embedding. We've tried it with both LSA, latent semantic analysis, which is the decontextualized type, and then BERT, which is a transformer based model that takes the context into account. So then we get a word embedding. And when we use transformers, we have the transformer usually have like 768 dimension. So each word is represented by 768 dimensions. And it's also possible to aggregate word embeddings. So even if you have a sentence or a text, you can describe that sentence and text with 768 dimensions. And then what we do is we put that into multiple regression in order to trying to predict a numeric value, which is here one of the rating scales, harmony life scale or satisfaction life scale. And we're using cross validation, which basically is we take 90% of all participant data and we fit the model there. And then we apply that model on the 10% that was left out, so that we get predicted scores for them. So then we have, and then we redo this procedure until we have predicted scores for all participants. And then we can correlate that with an observed value to get an estimate how well our models are. And this pipeline can also be extended so that we can get in both descriptive text and descriptive words for both harmony and satisfaction. And then we take the word embeddings and we concatenate them before putting them into multiple regression. And the sort of the best results that we've received is when we use a transformer-based model where we use word embeddings from both harmony and satisfaction using both words and descriptive text. So here we use all 4 word embeddings, and you can see that we can predict the harmony in life scale with a correlation of 0.85, which we then also, in a paper recently published, we compare it with reliability measures of, here you see the harmony in life scale. And as you can see that, for example, the item total correlation average is having a correlation of 0.84. And we discuss a little bit how the reliability can be seen as the theoretically upper limit of prediction accuracy here. So we are basically pushing that limit. From this and similar results, we argue that using this method, you can really measure psychological constructs really well. Then we also argue that, well, using this method, we get these unique experiences described with words or text, which can be used as both describing and differentiating psychological constructs. So here you have one example, which is the first word cloud that I did in 2016, and I was interested in the difference between harmony in life and satisfaction in life. So what you see here is data where participants have described their pursuit of harmony in life and their pursuit of satisfaction in life. And then we plotted statistically significant words that differentiate between these. And we found, very much according to our hypothesis, that satisfaction in life had more to do with self-fulfillment. So you have words such as money, job, achievement, education, fulfillment, work, which is very important parts of well-being. And for harmony in life, you get more interconnected words. You have words such as friendship, consistency, agreement, peace. Here you also have cooperation, empathy. So here we actually get a glimpse on what participants were thinking about when it comes to these psychological constructs. And here is another plot where you can see here on the left side in blue words, you have words that people actually use to describe their level of satisfaction with life versus their level of harmony in life on the right side. And if they feel like they don't have either of them, you get words such as tired, depressed, worried, unhappy, and bored. Make sense? Yeah, here we have another one where I'm comparing. Here we have depression versus not at all depressed. So people, when they describe their depression, they say words such as lethargic, irritable, empty, alone, numb. And when they describe the opposite, you have words such as enthusiastic, relaxed, hopeful, but also stressed.
Oscar, is that based on the paragraphs or just the words?
Yeah, good question. Most of all that I've showed you now have been based on descriptive words. I'm working on ways to better. You sort of get good word clouds for text as well, but then you also can get in words such as the, my, and those kind of things. We're working on functions to better plot text where you also will show, so you can scroll over a word and see the context, the most common context that they were used in, and things like that. So it's a little bit work in progress. But if you don't have a lot of participants, I tend to choose to use the descriptive words method if I want to plot them, because you get more, I think, more clean and powerful word clouds.
Thanks.
So here I wanted to highlight with this picture that a lot of the research in general in the field, and especially
Oscar, sorry, Ezekiel had his hand up. I don't know if you can see people's hands, but Ezekiel just had his up.
Sorry, no, I can't.
Yeah, I had yeah, I'm curious about one aspect. So how is it working with, you know, negation of concepts? So for example, I saw, yeah, for example, when you say stress, how is it working when you say I'm stressed versus I'm not stressed at all? So if the context is sufficiently covering these differences. Right?
Yeah.
Or for example, I saw fight within the cloud of harmony. So I guess that comes from negation of fight or overcoming of fight. So in the previous one.
Yeah.
So there's revenge and fight and so on. I guess that comes from the overcoming that or neglecting that somehow, right?
Yeah. I mean, that's an interesting point. And I think, like, in terms of pursuing harmony, you also have to disagree. You might have to fight, and then you can come into harmony. So like harmony in life, it's not just agreeing, being a pushover and agreeing to everything someone is doing. But this plot is used on descriptive words, and where we did not have any contextualized embeddings at all. Whereas this plot is this is very much work in progress, but here you have stress, which isn't depression. So over here you have not at all depressed. So stressed isn't that, but I would still be a little bit worried, because here you have worthless, which I would like theoretically think is sort of tapping into depression. Blue might also be, but maybe it's not strong enough. Like you have quite lethargic and unmotivated is what I would consider more stronger. But also this plot is not based on contextualized word embeddings yet. So I hope to get like better ones in due time.
Okay. Yeah, thanks.
So with this picture, I wanted to sort of point out that a lot of research in the field, and especially my research, we focus a lot on using NLP and ML to predict rating scales. But rating scales have disadvantages, limitations, and what we really want to look for is the true states, traits and states. So I think there we're trying to address this a little bit now. One such example is that we look at behaviors instead. So we made we did an experiment where we were looking at cooperative behavior, because we had the theory that harmony in life is going to be related to cooperative behavior, whereas satisfaction in life will not be. So we asked participants to describe their harmony in life, their satisfaction in life with both descriptive words and rating scales, and then they could participate in a social dilemma type of game called Give Some Dilemma game, where everyone were given $1, and then they could give that $1 to a partner, and the amount they give will be doubled by the experiment leader. So the more you give, that doubles to the other person, and at the same time that person can give to you, and if you both gives, you're going to get more money. So the more you give, the higher level of cooperative behavior we conceptualize it as. And what we found was that CLA, computational language assessment of overall harmony in life, correlate with cooperative behavior, whereas rating scales didn't. So that's sort of some initial result showing that computational language assessment might actually capture and also like differentiate between two otherwise very closely related rating constructs. So correlations between the rating scales are often very, very high, like around 0.8. But then
can I jump in with a question here?
Yeah.
Yeah, so you basically take the latent features of the text, right? And these best predict the prosocial behavior. Am I correct in saying that?
Yeah, we have two different ones. So one is when we can train models to predict the numeric outcome. In this particular study, we didn't have enough participants to do training. We had like 200 participants, I think. So what we did instead was we took their responses and then we have created what we call word norms. So we've asked 100 participants to describe what is high harmony in life, what is high depression, what is not at all depressed, what is disharmony. And then we get sort of 1,000 words describing what harmony in life is. And then we can take the semantic similarity between one person's responses and this word norms. And like that, we get a score.
Mm-hmm.
Okay. And then you don't need that many participants because you don't have to fit a model for it. So in this study, we are using semantic similarity scales.
Nice. Okay, yeah, thank you.
Yeah, thanks. And then a quite comprehensive study that we are carrying out right now is lead, which is seen as sort of the gold standard in psychiatry or clinical psychology, and it's basically a longitudinal method. So we have followed 1,000 participants, more than 1,000 participants. We started to follow them for 10 weeks. And then after 10 weeks, we got all their responses where they answered both rating scales and language open-ended questions. And we structured this into a highly detailed and structured report that we showed to clinicians. So the clinicians, they could then see, then we wanted them to assess participants, assess them at T1 using T10 data, so they could sort of see into the future what happened, and like that, in that way they could sort of make a better, more accurate assessment of a person. So we call this lead assessments, and with this assessment method we have sort of something that isn't rating scales that we want to predict, but now we rather want to predict this lead assessment, and then we can compare that with rating scales, and very early results tend to show that we can actually produce a model that correlates better with a lead assessment as compared to just rating scales. So that's another example of how we try to avoid just predicting rating scales, but instead comparing our method with rating scales. And then very, very quickly, like, this talk isn't about biases, but I think it's important to always sort of say something about the ethical concerns that you should consider if you use this method. The most common one is that language model, they gain their word embeddings or their text representations from the structure of its training data set, which is the corpus. And this comes with the risk that the model reproduces or even amplifies existing patterns of biases in the corpus. So have that in mind. I'm given a reference here as well. There are methods that you can do in order to mitigate biases. There's also a new language model where they paid a lot of attention to this that is called Bloom. I haven't tried it out yet, but can be worth checking it out. So then there's some, I'll make a pause for some questions if you have any.
Yeah, thanks for that. That's I have two questions actually. The first thing is I didn't quite understand the lead method. You were talking about you can see something into the future, and it wasn't clear to me how you did that. So can you just go through that again briefly, please?
Yeah, we basically in this report is based on all data, it's called, but it's based on longitudinal data. So now we actually have followed some participants for a year.
Okay.
And then we can give this longitudinal data to experts, which then can make a decision at this specific point in time.
Okay.
What is the assessment? Do they have depression or not? Or what would you consider the severity is? And doing this, we give them the advantage that you don't have in a clinical setting, is that you can actually, we are interested in something that happened here. So you get both data that is going to happen in the future, but we can also show very well-structured data, past data.
Okay. So in other words, you're asking experts at time T3 to make a diagnosis, and you can compare that to what ultimately happens. Is that the point here? Yeah,
well, you can take into account what happened in the future. So for example, depression, if you look at the DSM-5 criteria, you should have these symptoms for 2 weeks. Here we can actually follow them for 2 weeks and make sure they've shown these symptoms for 2 weeks. We don't have to only rely on self-report.
Okay. All right. And then the other question I guess I had, just to the ethics thing, that's an interesting point. So just roughly speaking, something like BERT, I mean, how biased do you think that is?
I think I actually don't know. We've looked a little, I mean, it depends on how you use it, what you use it for. We've looked a little bit on if there are any gender differences in prediction accuracy, for example, and we haven't found any bigger ones. But there are many examples in computer science where they use models that generate text, and the text that they generate is full of racism and things like that. Yeah, so it can be a big problem. You have to consider what the corpus they were made on, what that was, and also how you apply it, how you use it.
Lisa has a question.
Yeah, thanks. I also have two small questions. So first of all, I was wondering whether you all ever tried a model in which you also include variables on the person level, so to say, because I was wondering whether sort of constant answering tendencies, some people just always answering with very short, 2-word answers, other people writing novels to open questions, whether you include this in models and whether this makes assessments more valuable. And then on the other hand, so I'm not really using word embeddings or any NLP forms at the moment, and I'm more on the survey methodology side. And I was just wondering what you think the main downsides of rating scales are and the benefits of open answers are, because usually when we field studies, we see that participants are particularly confused by open answers and that they get stuck in the survey, that this takes much longer to answer open questions, and that we actually try to reduce them as much as possible, and that we rather go for scales that are, highly tested, and then we try to reduce and condense a scale because it's actually easier for participants to nail down what they mean with tested scales and instead of open answers.
Great question. I forgot your first question, so can I jump into the second one?
Sure.
You remind me about the first one. But I mean, we're working on this a lot, to be honest, and we have one study that we refer to as like response format, where we try to figure out sort of how long time does it take to answer these things, and also like how much do we need to get good predictions or good accuracy. But we also tried one where a response format that were just select words. So then you have a list. So then you understand. Then they very quickly understand what we expect, sort of. And this we can do on a data-driven way. So we've taken like the best descriptive words for harmony and disharmony, for example, and we list them. And then we can also provide the option of writing more words. But selecting words work really well. We've seen, and it goes faster than the rating scales. And we also get the option for them to describe more, so we can get these descriptions. But then I also think, but I don't have any data on this, but I do think that we often study complex psychological constructs that might require you to actually think a little bit about how you are, how you feel, and that this method actually enforces that a little bit, rather than just ticking boxes. Like ticking boxes, I think capture a very common latent variable. Like if you're very positive, then you tend to be much more positive. So that's why I think we see the satisfaction with life scale and harmony life scale, the constructs are quite different when we look at the word clouds and when we think about them theoretically, but still the rating scales are very highly correlated. But the computational language assessment measures that we get out are not that highly correlated.
Interesting. Thanks. May I quickly follow up on that for 1 second? But I would just like to push back a little bit, because I would also say that in open responses, right, if you trigger a response by just one question, this is a bit like asking a 1-question scale, right? Because people have to interpret that concept, what you're asking and what you're prompting, quite deeply, right? And when you have a rating scale, you can narrow it down by naming different dimensions of the or different behaviors of the concept, right? So you're sort of helping the participant. And on the other hand, I would also say that you also get some bias in the text when people reflect on this, right? If you think about people with different levels of formal education, they will express themselves just systematically absolutely different. And then this brings me back to my very first question on like answering styles, so to say, right? Some people just always saying like, yeah, I'm good, I'm bad, full stop, that's it. Or other people like writing novels, right? So yeah, full stop.
Yeah, no, I like good reflections, and you're right. To the first concern, I'd say that for depression, when we want to get the diagnosis, their symptoms, like sleep, concentration, etc. So then we also ask those questions. So first we tend to also open the very open one, like describe your mental health. How are you feeling right now? And then from there we can zoom in and ask, okay, but describe your depression. Do you feel depressed or not? And then we zoom in even more and ask, okay, but describe your sleep, concentration, and like that we can capture everything as well. And first we tend to start with describing a text, and then the symptoms is often like select 2 descriptive words or provide something else. And like that, we can cover quite a big chunk of it. And then we've also looked at like one single word can do quite a lot, but it gets better the more you have. In this data set with the lead data, we have also looked at, we have collected dyslexia, so they can self-report that. I don't have any results on that yet, but we'll have soon.
Interesting, yeah.
Yeah.
We have another hand up. I don't know if you finished with your response, but we have another hand by Ezekiel.
Yeah. Yeah, I had another question that I wanted to ask if you have maybe considered to somehow bootstrap this kind of classification, in the sense that you had, for example, let's say a set of texts belonging to these 2 labels, these 2 classes, for example, and for the same kind of participant, you could ask them to classify that, for example, just to maybe as an attempt to double check that there's no incongruencies between within the use of the language model for this task. You know what I mean? So, because it's like you are, so we're using the language model to derive to classify basically, right? But based on a scale. So we'll give you an idea, for example, to have already a set of maybe generated or even real texts from previous participants, and for a new sample of participants, you made them classify that, and you check how good they are at that. So how consistent is the whole thing?
Yeah. We had a project doing something similar to that, but I can't remember what happened to that project, to be honest. But I'm having one now where we make models, and then we have a master's student rating things as well. So you can, and then we see what we're interested in there is really to see when the model is becoming better than the student. But here we can also see that sort of things tend to make sense. So it's quite exciting to see that first we just use descriptive words, and we want her to describe the valence of them. And there her own were better than her own model. But then made it a little bit more difficult. So we took Facebook status updates. And there we could see that the longer text, for the longer text, her own statistical model became better than herself. And now we've asked her to look at the lead data. So we made the language task more complex, so she has to look at a lot of different texts and then assess depression, not only valence but depression. And the hypothesis is that her model is like the model based on her answers is going to be better than her own estimations, because the statistical model is sort of getting more reliable than she can be.
Okay.
So that would also sort of indicate that things are sort of making sense here. Another thing that we haven't done is also look at the cases where the predictions are most of like the biggest error in the actual prediction. If we could see, maybe there we could see what Lisa was into, that maybe shorter answers is going to be the ones that has highest error. Yeah, but I mean, I think this is an exciting field. There's a lot of low-hanging fruits, things that can be done, which would be really useful.
Yeah, indeed. Yeah, thanks.
Yeah, so a little bit short. Do I have more time?
Yeah, there's another 12 minutes.
Yeah, but so there's been an explosion of creation of language models in computer science, and Hugging Face is the place to go where you can browse all the different language models, and you can use them as well. You can download them and you can use them in your research, and they can be fine-tuned as well to sort of understand to quantify specific text better than other texts. So they can be fine-tuned to understand clinical text, for example, better. And everything is basically happening in Python, PyTorch. There's a lot of different packages there. So when I started my postdoc, I was thinking I was going to go in and start learning this, but then we thought, well, actually I was using R, and we found a good way we use Reticulate, which is an R package that can incorporate Python code very, very well. So in the background, we are using Python and Hugging Face, but we give an interface in R that you can use if you're used to using R. I work quite hard on trying to make it really easy to install. So you can install it from CRAN. When you have installed it, you have to run one function, just run this in order to install all the Python related packages that you need for running this. And then after that, you just run this function in order to initiate your environment, your Python environment that was created with this first function. And this you only do the first time when you downloaded it. And then you can start using it. One of the first step is using the function text embed and then insert your text data. So with this row, you actually get numeric word embeddings that you can use in your own pipeline for whatever you might be interested in. But we also provide a bit more high level functions where you just give, for example, train here. If you want to create a model, you provide it with the word embeddings that we did in the previous step, and then you provide it with the numeric outcome that you want to predict. And you wait a bit, you hang back, you go for maybe not a coffee, but both a coffee and a walk. And then you get a model with results and predictions. Yeah, so we see the TeDCog package as both a modular solution and with high level functions and end-to-end solution.
Fantastic. So if I got 100 people's questionnaire responses in one column, not questionnaire responses, I mean, they're open text in one column, and 100 personality scores, whatever they are, in another column, then this one command will give me we'll try to train the word embeddings to predict that personality, and will tell me what the correlation is. Is that right?
Exactly. So it's two functions, and this one takes some time as well. It depends on what kind of computer you have, but this takes some time. If it's good responses, 100 participants can produce quite good models, but then the models get better and better the more participants you have in your model. We've written a tutorial that is under review at the moment, but we have it as a preprint that you can check out how to install and how to run the most common ones, and it's quite easy to do, like word clouds in here as well.
I just want to endorse the text package. I use it all the time, and I absolutely love it. So any R users here in the crowd, please download and use text. And I'll get a bit geeky now and ask for a little bit about the under the hood, because basically from what I figure, this is a downstream modeling approach, right? So you basically extract the embeddings, and then you take those embeddings as features and in a regression model. And you started this section, this very small section of the talk by saying that you could, that what you usually do with models like BERT is to fine-tune them, which is a bit of a different way, by using the fully connected network or just using the this downstream modeling approach. And I was wondering if you have any comments on that, or maybe this is something that you maybe this is a future feature that you're going to release in text, hopefully.
Yeah, great question. And on Monday, I actually meet a PhD student in computer science at Stony Brook University. We're going to meet online, and he's been working on exactly this, fine-tuning the models. So I know very little about how it might improve the data that I have. I know very little about how much data. I know, like, you should have quite a lot of data, but we are planning on looking into sort of if and how it can improve our type of analysis. So it's on its way.
Thank you. Right. So I think we have 5 more minutes for. I don't know if you're done with this section, Oscar, if you have another more slides to cover.
Yeah, no, I don't have any more slides. I could just point out in one of Lisa's questions, I also wanted to point out that when you train a model like this, we also have a function here where you can add numeric values to the word embedding. So you could add for personality, like the big 5, you could add word embeddings describing it, and then to the word embeddings you could also add rating scales describing openness, and then see if you can with that make a really good model describing and predicting agreeableness, for example. So you can add a lot of other numeric variables basically to the pipeline, and we also have some functions where you can so this is very like you can also significant test 2 different models to see if the model with more data in it is significantly more accurate than the other one. I also think it's open up quite fun user cases here, because you have to remember that here you get a model that you can apply on new data sets using text predict. So in one study I can make a model, and that model I can then bring into another study to predict things with.
Yeah, on that, does this function do any cross-validation, or is that something you got to wrap around it?
No, this one is doing that for you.
Okay, so what is it? A k-fold? What's the default? What?
Tenfold is the default. Okay. And here I've been very fortunate. Like the Andrews group, they've been working a lot on analyzing, predicting like psychological constructs from social media data, and they've been really nerdy in trying to figure out sort of which algorithm and how to apply them, what is the optimal. So all that knowledge we've been able to sort of put in here. So the defaults is already quite good. So you can just run this, but you also have setting if you want to try other settings.
At that correlation there, the 0.78, is that an out of sample prediction, an average of the 10 out of sample predictions?
Yes.
Okay.
Exactly.
Okay.
Well, I think we have another minute or 2 for question. If anyone has any questions or comments for Oscar. And
I've left my details, contact details. So feel free to let me know if you have any questions or any feedback on how the package can be improved or so. I'm happy to hear that.
Okay, great. Well, I thought it was super cool, and the package looks really great. So I'll have to install that as well. I know that Almog has been using it, but I mean, yeah, no, it's fantastic. Thank you.
Yeah. I don't really have a question. I just want to say this is really cool, and we've got some like text data that I'm just thinking actually maybe we could try something like this on it. But it's basically anti-vax stuff. So
yeah.
Oh, nice.
And related to sort of deeper personality constructs. So like, we've got open-ended data that might work. So thank you very much.
Yeah, thanks. Yeah, try it out. That's how I started as well. Like in the beginning, it was just a side thing. We got some open data, and then it worked very well. So then I got more and more into it.
Well, thank you so much. This has been really great. And yeah, we'll be uploading this to a YouTube channel. So I hope more people could enjoy the talk. So thank you. And yeah, I think I'll stop the recording right now.
Yeah, thanks for having me. And thanks for the questions.
Bye.
Bye.